Okay, today we're taking a look at this prototype missile robot. It's dated around 2011 to 2013, somewhere in there. The piece of paper I have, it says Miyazawa Horikawa Brothers, apparently affiliated with Metal House at that point, did this prototype. And what's unique about this one is it uses a flexible metal belt drive to send a missile way out, and of course that's the part that's broken, and here's part of the body stuff that's off and out of the way for the moment. So let's set that over here, and I've 3D printed a part so that we can get an idea what it's supposed to do till we can get an actual metal part made. So it's got the long missile that comes out unbelievably far, and if you keep holding the button, then it should go back down there, like so. It's a very complicated toy. I'm going to show you how everything in here is supposed to work, and it can't work. As you saw, I had to give it a little bit of help to get the door to open. It can't work completely on its own with this 3D printed part. This is a 3D printed nylon part. Basically what that represents is, you see this very thin spring steel piece here? Well, there's two more parts to it. It's in three parts. This piece is supposed to be attached there, and then this piece is supposed to be attached there to form the whole cog belt, if you will. And it's being a spring steel and very thin, 0.06 on the thickness. You can't really emulate that with a 3D printed part. In fact, this nylon one, I had to print it 1 millimeter thick just to get it rigid enough so that it could do the pushing that this can do. So it's going to be a tough part to replace. Generally speaking, you don't drill spring steel. You can untemper it sometimes and drill it, but normally it's punched. And it's got all these holes that have to be spaced exactly right. In this case, they're spaced at 7.3 millimeters apart from each other. And from the first hole to where the first hole in the sequence begins has to be a particular distance as well. Actually, this is the back end. The front end is the end that's broken off. But you might like, if we move the camera closer, so we can get you some close-ups here. The mechanics are really quite amazing. Now, besides the rocket function, it also has a walk function. So if you push this button, you can see then it walks. It uses one motor, and by reversing the motor it throws a gear to the left or to the right. So if it throws it one way, let's see how good the camera is at picking some of this stuff up. So here's your motor. This is the screecher barks, that sound that you heard when the missile was going up. That's controlled by this moving. Doesn't move a lot. Has this ramp sequencer, which we've talked about in the past. Moves up and down, moves the shaft up, it pushes on this lever, and that moves the screecher on or off the gear. But back behind that gear, you can see part of it here. See this piece right there? That's around the motor shaft, and back here there's a gear. So depending on which way that motor is turning, it'll tend to want to throw the gear to the left or to the right. If it throws the gear this direction, it's going to interface. Let's see if any of it's visible from back in here. Not really. It's going to throw the gear over to this shaft, interfaces with a gear up there, and this drives this little white plastic gear. It's unfortunate they had to put a plastic in here because someday that gear is going to fail. And then that white plastic gear drives a shaft, and clear back in there at the end of that shaft, if I can get the light right, there's a worm gear. and then that worm gear drives another gear, which ends up driving the crank to make it walk. It's really amazing how much stuff they put in this one little teeny area. So that's how it walks. But if you reverse the motor, make it run the other way, that little gear flips over, and you can see that long one with all the teeth all the way up and down. That's what's going to drive the two rotating ramp sequencers. And as you know, the way this works is there's one of the gears has one tooth more, or depending which gear you're looking at, one tooth less than the other. So they're not turning at the same speed. And then there's a ramp, which you can actually see poking down through the hole there. And as it crawls its way around, it spreads the two gears apart, which move the shaft. The shaft moves the squeaker, and the shaft also brings this little piece down to this flasher, because there is a light, even though it's not visible, that flashes down in there. But more importantly, it moves this gear down here. You've got a crown gear here, and you've got a gear here that when it's up, it drives the crown gear from the top side. But when those two have separated and the crown gear moves down, it now drives the crown gear from the bottom. So what that does is, one way this crown gear is going to be turning clockwise, and one way it's going to be turning counterclockwise. And that crown gear runs back here. If I pull some of this out of the way, well, I guess you can see it from the top side easier. You've got a cog. You can see that cog. I'm making it move a little bit. And those teeth interface with the holes in this piece, which is supposed to have been stainless steel so that it can push better. And that's what drives all of these telescopic sections. Let's see if we can take this part off so you can get a really good idea of what we're talking about here. This blue thing is a sounding box, so the squealer's louder. There we go. We're going to look at that rocket assembly in a second, but now you can see the cog, and then right below it there's two pieces of metal that push up, so when your cog belt goes through there and then tucks up through that slot and then comes up through here, keeps everything tight on the cog. So what you have is this rocket section. If I get far enough back so everything's in screen. The one hole in the end of that flex shaft that I showed you earlier connects on there at the very top of the missile part, so that as you pull that piece in and out, all these parts will be telescopically moved in and out. Got to hold it in the right place so I'm not binding stuff up. So this plastic is not the answer, but I had to do the plastic in order to make sure that I had the math and the spacing right before I try to commit to having this part remade in metal. So right now we'll be trying to contact some machine shops to see if I can get them to do that at a reasonable price. If I can't, then the flex steel that we're talking about, if this 0.06 millimeter, which if you're in America would actually be 0.00023622, very thin, is normally thought of as like shim stock, stainless steel shim stock. And again, the holes would need to be precisely punched, or I guess if they had a laser setup, they could laser it, or an EDMF wire. No, I don't think you can use the EDMF. Well, maybe you could. But at any rate, if I can't get a machine shop to do it, then I will have to try to cut a piece of spring steel exactly 6 millimeters wide and 262 millimeters long, and try to punch these holes exactly in the right places so that everything works. But I thought before we got into all that, you all might really enjoy just seeing how amazing the design work was on this here. Now you can see the white gear that drives the shaft that goes down to the legs to the worm gear, and the worm gear drives the crank to make the walking work. You can also see some of the gear work from the inside in here too that we talked about. It's really quite amazing how much mechanics and gearbox work and shifting two different functions, actually three functions, because it selects walk or missile, but when it selects missile, then it's actually running another function, which is the sequencer. So you really have three functions going on there, all in one. But that's what's inside the amazing missile robot, and stay tuned for updates on how getting a new flexible, we'll call it shim stock or spring steel flexible cog drive belt